What's up, guys? Today I want to do another smart contract hacking video for you guys here. In this video here, we're going to be doing Fallout through the Ethernaut series from OpenZepplin. Now, if we go to the little menu here, we can see that this is the third one in the series, labeled O2, because the first one is a tutorial and they do it like a computer array, so it starts at 0, 1, and then 2. If you guys haven't watched my other videos on the tutorial and on the Fallback, be sure to watch them here. This one's going to be pretty easy from here, so I'm going to do it and then I'm going to kind of talk backwards because I think that when you see it, you're going to be like, oh yeah. By the way, in the other videos, I included a link here for the Gorilla test faucet from here. I'm going to go ahead and log in here. I might have to cut the video. You do need an Alchemy account here to stop the spam attacks, like they said. It looks like I am already logged in here, so I'm going to go ahead and get my address here. Now, by the way, if you do this, make sure that you're connected to the Gorilla test network here. You can actually submit this, but if you're not on the right network, it's going to just submit the transaction, and you won't get your test Gorilla, but the transaction will still go through, so you have to wait 24 hours before you can get it again. I'm going to go ahead and exit that out, and we can close it out too here, and we'll let that go, and let's go back to our smart contract. So let's go ahead and scroll down here. Let's go ahead and get a new instance here. You can see that obviously I did this one off camera just to make sure that I could complete it in an efficient manner, and that I don't make too much of a goof of myself here. So while that's processing here, let's go ahead and take a look at the contract. SPDX license identifier MIT here, Pragma Solidity greater than 0.6.0. Import OpenZepplin contracts. OpenZepplin contracts 06 math/safemath.sol. The contract name is Fallout. And when you're kind of looking at these contracts, always be sure to look at stuff like curly braces. Obviously, if you're using something like Remix, it kind of does it for you. But sometimes with these quote-unquote hacking contracts here, there's different small things like that that kind of come into play. Anyways, from here we have this curly brace there. That's looking pretty good. I think everything is within the contract, so that's pretty good. Using safe math for UN 256, mapping an address to a UN allocations, address payable public owner. Cool. So we have the constructor from here, and the first thing I'm looking at with this constructor is that why is it not a real constructor? We have this function Fallout. It says it's a constructor, but it's not actually labeled a constructor. You can see that I'm actually working on the next video right here off the side here. A constructor is the keyword constructor. The constructor is a function that runs one time and only one time when the contract is first launched. And usually you see people set things like this here. You set the owner equal to whoever calls the contract. You see different values being set here. This one, it's kind of weird that they're doing that. Not a real constructor. They want to deploy the contract and then call the constructor. That's very odd. So we'll come back to that there. We have a modifier for only owner. That's looking pretty good to me, although the spacing does look a little funky, but I think that's good here. We have a function for allocate. Allocations message sender, allocations message sender, add message value. So we have basically a ledger of different people putting money into this contract. From here, putting some type of value into this contract. Send allocation. We have address public allocator public. Address payable allocator public. Require the allocations of the allocator be greater than 0. Allocator.transfer, allocations.transfer. So all this looks pretty good here. Really what I want to do right now is I want to call I want to mess with this a little bit from here. Let's go ahead and scroll up here and let's see what our goals are for this here. It actually does not say. Claim ownership. Okay, claim ownership of the contract below to complete this level here. So let's go ahead and open up our console from here. We can see that we have our instance address here. Like I said, this one's pretty simple, so I would open up another tab and take down some notes here, but it's going to be pretty simple from here. I'm going to await the contract, and let's see what information we get back from there. If we drop this down, we can look at our ABI. In our ABI, we have 6 functions in total from there. 1, 2, 3, 4, 5, 6. Now, if I go to contract.owner, let's see who is the owner. The owner is not set yet. So all I really need to do is set my address to be the owner, which would be right here already. I'm the one calling this here. So all I really have to do is call this function from here. So if I call await /contract dot fallout with a capital F there, and I try to call it, we're going to see that, wait a minute, that's not a real function. If you look ever so closely from here, this L is actually a 1 from there. So I'm going to copy that there, and I'm going to go back. I'm going to call the same function again here. But this time I'm going to say FAL1 out, and we're going to call that, and our MetaMask pops up, and we're going to confirm the transaction once it, confirm it, once it estimates the gas. And hopefully the contract isn't too busy when this goes out pretty fast here. Cool. So now we have a transaction confirmed here, and if we go back and call the owner, we're going to see it now. That's my address from there. So all this other stuff, we could poke around this some more here, but really we did what we need to do here. So let's go ahead and submit instance, and let's see if we did it properly. Let's see if we cracked this contract, as simple as it was, confirm. And we're waiting, and we are almost there. I'm gonna make sure I'm still recording. We're looking good, and well done. You have completed this level. So guys, we beat this level pretty simply from here. And realistically, if we go back, or not realistically, but if we go back and we kind of just analyze what we did here, the clues are usually here. You can see that this right there is like an error, right? If I type in something in a Word document and I spell something wrong here, it's going to give me that underlying error, or even in like a Visual Studio Code here. So that Fallout, I guess it's like a little one on top of each other from there. Number one, the constructor wasn't set up properly, and number two, that name wasn't correct either. So, if you read this paragraph from here, that was pretty silly, wasn't it? Real world contracts must be much more secure than this, so it must be much harder to hack them, right? Well, not quite. So basically, there's a story of Rubixi, hopefully I'm pronouncing that right, a very well-known case of the Ethereum ecosystem. The company changed its name from Dynamic Pyramid to Rubixi, but somehow didn't rename the constructor function and the method of the contract. Contract Rubixi, address private owner, function Dynamic Pyramid, owner equals master sender, blah, blah, blah. So anyways, it's important when doing this stuff here, if you're a smart contract auditor, or if you're writing smart contracts out yourself here, always be very careful, right? Everybody makes mistakes. Whoever made this mistake here, they're probably a pretty good, I would hope, even though it's a very silly mistake, they're probably a pretty good smart contract writer. And it's not like they're, some 12-year-old kid or something like that there. Everybody can make a mistake, and this is why it's important to, number one, not rush your work, and number two, not be too hasty when you're doing stuff. I guess that's the same as rushing work, but always make sure you double check all of your work there, right? I know I've done it before where it was like something very simple, like an if statement. And like, I'm sleep deprived, I'm trying to get this gig done, I'm trying to do whatever here, I got a million things going on here. And the if statement is like, if 2 doesn't equal 3, I'm trying to trace back the issue, and I'm making it as simple as possible. If 2 doesn't equal 3, then do this. It's like, why isn't that running? Oh, because 2 doesn't equal 3, right? It's evaluating a true statement, and that's why the if is going there. But hopefully that makes sense. I'm not really doing a good job of describing there, but always make sure that before you, and especially with the nature of the blockchain, if you do anything here, always use tools to test your smart contract, and always, always, always be 100% certain before you deploy. If you deploy, and you know this, if you're a Web 2 coder going from Web 3, if you deploy a website and there's a little typo, that's no big deal because you can change that. But if you deploy a contract and you figure out there's a huge security flaw in here somewhere, where all that contract's gone, right? It's immutable data based on the blockchain, so it's always important that you guys be careful with your stuff here, all right? Anyways, if you guys learned here, if you guys learned something, be sure to give me a thumbs up, comment down below, and subscribe. Hopefully I didn't rant too long here, but this stuff is very important. Like, we all make a mistake, so if you make a mistake, it's not the end of the world, but just make sure you catch that mistake. Anyways, guys, I'll see you guys in the next video. The next video is going to be a little more fun, and I hope you guys have a great day.